Hello all. Today we are going to learn volume by cylindrical shells. In previous two classes, we learned volume by revolution that had two parts. The first part was volume by revolution washer method, and then volume by revolution disk method. Now this is the third method that you could use to compute volumes. This method is called volume by cylindrical shells. All right. So the approach for this section is mostly similar to the approach for the previous two methods. All right. So let's go forward. First of all, I will just give you some motivation. Let's consider I have this shape to compute the volume. This is y, that is x, this is c, and I have a shape like this. And then so this is the shape. This is a 3D object. You can visualize it. It has a whole interior. Okay, it has an empty interior. That is the empty interior. All right, so let's see how to compute the volume of this. For this experiment, sometimes the previous two methods won't work. Those methods were the disk method and the washer method might not work. So here what we're going to do is we're going to use the shell method. Now what we do, let me consider a region. Then I will explain why I consider that region. So let me consider this region. Let's say this is x. That is y. Let me consider that region. Now what happens if I rotate this region about the x-axis? Sorry, about the y-axis. Now what I'm going to do is I just rotate that region about the y-axis. If I rotate that about the y-axis, I will be able to get this shape. Okay, so I will be able to get that shape. So then in that case, I have to switch. I have to switch this one there, that one there if I need. So that's all right. So I will just keep as it is. You can understand that. So rotation of this thing will give you that thing. All right. So let me put another arrow. Rotate about the y-axis. Okay, so if you rotate it about the y-axis, you will be able to get this shape. That is we learned in our previous class. Okay, that's what we learned in the previous class. In today's class, we're going to do something different. So let me copy this. Let me mark here. We learned this in the previous class. That's mostly the washer method. This is mostly washer method. Let me take some space. We learned the washer method. That is right below. That's what as I explained here, the washer method, because it makes washers. This makes washers, as you see. If you make a cross section of that, if you just make cross section of this object, so what you get is something like this. So this is your X, that is your C. So the cross sections are like that. They are washers actually. So you could use the washer method that we learned in the previous day's class. This is a cross section. All right. Now we're gonna learn a new method, which is called volume by cylindrical shells. Now what we do, rather making washers or discs, we just cut cylinders. We just cut cylinders by going down like that. Okay, we just go down like that, and then just let's say we have some block or something, so we can press it right here. Then it makes small cylinders. Every time we press it down, it makes a small cylinder. All right, so now what I'm gonna do is I can make a cylinder like this. So this is the shape of the cylinder. So these are the cylinders that we make. All right, so you take this cylinder out. You take the cylinder out, and then it should look like this. All right, then what we do is we just cut the cylinder like that. We cut it like that. Okay, we cut it like that, then unfold it. Cut and unfold it. If you cut and unfold it, so you get a stripe like this. You get a long rectangular piece. Okay, so this has a small width, very small width. Give me a second. All right, so you get a stripe like that. So you can understand. Let's say you are given this shape. Let's say you are given this shape, and then you just make a cylinder like this. Then you cut the cylinder. You can just take a scissor and cut cut like that, and then you can just unfold it. So you will be able to get this object. All right. So that object is a rectangle, but it has a width. It's a kind of a box with small width. Okay, it's a box with a small width. For this box, you will be able to compute the volume. Okay, let's say this function is f of x. Let's say that function is f of x. If that function is f of x, this height is f of x. All right. If that height is f of x, this height is f of x. And then consider this displacement is, this is x-axis, and let's consider that displacement is x. If that is x, this is also x. All right, since that is x, this length is actually the circumference, right? That length is actually the circumference of this cylinder. All right, then what I write is this length should be the circumference. That should be 2 pi x. Let me write something extra here. The circumference of the cylinder. This is the circumference of the cylinder. All right. So this is the motivation of that. We just make a, I would say, a stripe. That's all right, because the width is so tiny. You can consider that as a stripe with a small width, or maybe a box. You could also say a box with a small width. You once you have this box, you can compute the volume of that, and then you add all such stripes. That will give you this object, the volume of that object. All right, so that's the motivation. Now just write down the theory part. Shell method for computing volume of a solid obtained by rotating about an axis. Okay, the first formula is integration from x equals a to b 2 pi x f of x dx if rotating about y-axis. Okay, now let's go back. The volume of this one can be given as, the volume of this object can be given as f of x times 2 pi x. All right, and then there's a small width. You could just consider this width as dx. All right, so that's the volume. Just take this. This can be considered as the area. The surface area should be multiplied by this small width. All right, this is the surface area, should be multiplied by that small width. I would say this is the surface area. Area equals that. You see, that quantity is right here. That quantity is right here. Now you can understand how this comes. Actually, that is taken from this area. All right. Now let's write the next equation. Next equation is v equals integration y goes from c to d 2 pi y fy dy if rotating about x-axis. All right, if it is rotating about the y-axis, you have dx here. If you are rotating about the x-axis, you have dy here. Right, and the limits from here a to b, here c to d. All right, now let me mark a and b here. A and b are actually, a is right here. This is A, the start of the cylinder, and this is B, end of the cylinder, whatever the object. Okay, so inside is hollow, inside is empty. So this is the start of the solid part, that's the end of the solid part with respect to the x-axis. So those are A and B here. Now let's do some problems. Example number 1. Now I'm moving to example number 1. Find the volume of the solid obtained by rotating the region bounded by y equals 4 minus x minus 2 square and y equals 0 about the y-axis. Okay, the first step is to make a plot. So the first step is to make a plot. So I'm going to make a plot now. First of all, you have to draw this region. The region explained by that, and then you will get a something interesting. So let's draw one by one. This equals y equals 4 minus x minus 2 square. Okay, what happened when y equals to, now I'm going to draw this parabola. What happened if y equals 0? I have to find few points. For that, just I plug y equals 0. If y equals 0, I have 4 minus x minus 2 square equals 0. That means x minus 2 square equals 4. That means x minus 2 equals plus or minus 2. And then x equals, first consider the plus and then consider the negative case. X minus 2, x minus 2 equals plus 2, or x minus 2 equals minus 2. That means x equals 4 or x equals 0. Alright, so those 2 points are x equals 4 and y equals 0, and x equals 0 and y equals 0. Alright, so let me mark those 2 points. Let me mark those 2 points later. Now I know 2 points, and then we have to find another point too. Okay, now first we plug y equals 0. Now just plug x equals 0 and find the corresponding value for y. Alright, so let me do that. Give me a second. No, I think that does not work. Okay, that's all right. So then what I do, I just mark these 2 points. This is my x-axis and that is my y-axis. It should go through 0, 0, which is right here, and should go through 4, 0. That's 4, 0. Okay, so it should go through those 2 points. All right, and then we should need 3 points in order to draw this parabola. Now we have to find another point because we have only 2 points. The next point can be found by differentiating this function. Once you differentiate that function, you will be able to find the maximum of this function, and that point, the maximum point, will be the third point. You know that y equals 4 minus x minus 2 square, and then I get the derivative of y, with respect to x. So I will get minus 2 x minus 2. So let's plug 0 to that. You have learned this in Calc 1, how to find the maximum point of a function. So you just get the derivative of that and then plug that to 0. So and then solve this function. Minus 2 times x minus 2 equals 2. This will imply x minus 2 equals 0, x equals 2. So that is the maximum of this function. The maximum is at x equals 2. The corresponding maximum value is this. So you plug 2 to this function. It is 4 minus 2 minus 2 square. So that is just y equals 4. Alright, so let me pull this little bit down. Let me say at x equals 2, that will have at x equals 2, this will happen. Let me add a small note here. Now find the maximum of the function. So that will give you the last point. The third point is 2, 4. So here 2, here you could say here 4. Okay. Now you have 3 points. So now you can just draw the parabola. The parabola will look like this. This is the parabola. Give me a second. I will just take it this little bit down. This is the this is the parabola. Y equals 4 minus x minus 2 square. Alright, that's that parabola. And then it says another line. So let's consider that. That line is y equals 0. Okay, which is right here. Y equals 0. Y equals 0 is that. Okay, now the corresponding region is this. So this is the corresponding region. You rotate this region about the y-axis. About the y-axis. That means you rotate like this. Okay, once you rotate like this, you will get a complicated shape. You can imagine that the shape should be 3D. I'm not sure whether I can draw that. I will try to draw it. So this is the shape you get if you rotate that about the y-axis. That is 4. This is minus 4. This is 3. Alright, and then I will draw this. I don't know whether you can imagine that. So this is the shape. It's again hollow inside. Okay, it's hollow inside. This is the outside of that. Alright, now we're going to use the cylindrical shell approach for this. Alright, so first of all, let me make a cylinder here. So this is the function we have. So this is the function we have. Then let me make a cylinder. The cylinders will look like this. Give me a second. It is hard to draw actually. I will try my best. Okay, that's the shape of the cylinder. If we cut cylinders on this object, if I make the same cylinder here, it will look like this. Sorry. Okay, the height of the cylinder is that's what we have to understand here. The height of the cylinder is actually this function value. Okay, which is what? 4 minus x minus 2 square. So that's the height of the cylinder. And that is x, the displacement of x. Okay, now this is a case where we rotate about the y-axis. Now we have to find the corresponding formula. So this is the corresponding formula, rotation about the y-axis. And then you have to find how these variables, the inner radius and the outer radius, how x varies. Okay, the x vary here, in this case, x varies from 0 to 4. All right, let me rewrite this problem. I'm going to use this formula. I'm going to use that formula. It is V equals x goes from A to B, 2 pi x f of x dx. This is A goes from, x goes from 0 to 4, and then 2 pi x, f of x should be this, that is 4 minus x minus 2 square. So this is now, once you are here, that is simple integration. All right, from here it is simple integration. Setting up this equation is little hard. I know that. So you have to just learn from the beginning. I explain it step by step how to set up this equation. All right. So now I'm going to use simple integration. So 2 pi is a constant. I took it out. And then I write x goes from 0 to 4. Here it is x. And then I expand the interior. That is 4 minus x square minus 2x plus 4 dx. And then I multiply the entire equation by x. Before that, I see here, I can cancel this plus 4 with this minus 4. You can see it's minus here. So you can cancel like that. And then I rewrite the problem as 2 pi from x equals 0 to 4 x times minus x square plus 2x dx. All right. The next step is 2 pi x goes from 0 to 4 minus x to the power 3 plus 2x square dx. Alright, now it is the power rule, simple power rule, you can remember that. The power rule for integration should be x to the power n, dx should be x n plus 1 over n plus 1. That is the formula I'm going to use here. Alright, here I write equal 2 pi minus integration of this one should be x to the power 3 plus 1, 3 plus 1. Then I have to put the limits from 0 to 4. Then plus 2 I can take plus 2 out. And the integration of the x to the power 2 should be x to the power 2 plus 1. Here 2 plus 1. And I have to put the limits from 0 to 4. Right, so let me change these brackets. I put curly brackets here. Right, then let me simplify further. 2 pi minus x to the power 4 from 0 to 4, then plus 2 over 3 x to the power 3 from 0 to 4. Alright, and then simplify further. 2 pi minus 1 over 4, 4 to the power 4 minus 0 plus 2 over 3, 4 to the power 3 minus 0. Alright, then you have to simplify this. This equals 2 pi. Here minus 1 over 4 multiplied by 4 to the power 4. And then you can cancel 1 4 here with this 4. And here it is plus 4 times 3 is 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. Here 2 multiplied by 64 divided by 3. And this is 2 pi minus 4 times, this should be 3. Alright, so 4 to the power here, 4 to the power 3 is 4 times 4 times 4, which is 64. So you're minus 64. Here plus 2 over 3 times 64. 3 is a common denominator, so you can get 3 out. Simply what you are doing, you are just writing 64 multiplied by 3 divided by 3 plus 2 times 64 over 3. That is the notion of common denominator. So I can take this 3 as the common denominator. So I write 2 pi, I take 3 the common denominator, and this is 64. I can take 64 out, and then here it will be minus 3. Here this will be plus 2. What I am doing is I am taking both 64 over 3 out. Let me put like this. I am taking both 64 over 3 out, and then this is what I get in the other side, in the other part. Alright, so this equals 64 times 2 is 128 pi over 3, and simplification of that one should be minus 1. So I put minus 128 pi over 3. I made a small mistake. Let me check it. Give me a second until I check. Oh yeah, the mistake is this. Actually this should be not 2. That should be minus 4. Okay, why it is minus 4? The expansion of that. The expansion of that should be something like x minus 2 times x minus 2. You just multiply that x with that, that is x squared. Then you multiply this x with that, minus 2x, and this 2 with that x, minus 2x, that 2 with that, minus 2, plus 4. So it is x to the power 2 minus 4x plus 4. Okay, so that should be right here. That's a typo, I'm sorry about that. Now let me make the correction. Since this is minus 4, you will get plus 4 here, and then plus 4x there, 4x squared there, and then 4 here, and then 4 here, and then 4, 4, 4, 4, 4, 4, 4, 4, 4, 4. So this will be plus 1. Alright, so this will be plus then. Okay, so that is the corresponding volume. Alright, so why I suspected that I have an error or a typo, because I got negative here. This can be negative because this is a volume. Since this is a volume, this can be negative. That's why I found like why this is negative. Then I found the typo right here, the error right here. Alright, so anyway, it's good now. So this is the solution for that problem, and let's move to the next problem. Example number 2. Use the shell method to find the volume of the solid obtained by rotating the region bounded by y equals square root of x and x in between 0 and 1 about the x-axis. In the previous case, we were rotating about the y-axis. See, we were rotating about the y-axis. In the new problem, we are rotating about the x-axis. Okay, the given information is this function is given to you, and that is given to you. It is rotating about the x-axis. Right. First of all, we have to draw this. Let me draw the shape. The shape will look like this. Let's see, this is y. That is x, and that is y equals square root of x. The shape of that should look like that. All right. So this is y equals square root of x, and then it says x is between 0 and 1. Here x is 0, here x is 1. Right, so this is the corresponding region. That is the corresponding region. So you are rotating this about the x-axis. If you rotate that about the x-axis, the shape you get is like this. Let's say this is x. This is y. And the region will look like this. The shape will look like this. The 3D object will look like that. Alright. Now we have to make cylinders on this. So the cylinder that I would prefer should be like this. This is the way I make cylinders. All right. Now you have to find the parameters of the cylinder. You could consider that length as y. All right, and then you have to find the height of that. All right, so the height of that should be that. Okay, so this length should be taken. All right, you know this function is y equals x square root of x. Y equals to square root of x. That means this is the corresponding x, that is the corresponding y. Okay, now you need this part. Why will you need that part? That is the length of the cylinder or the height of the cylinder. Do you see that? That's the height of the cylinder. All right. Now this part is actually, that is 1. This is 1. This part is actually 1 minus corresponding x value. Okay, 1 minus corresponding x value. So this is x. So that part should be, let me use a different color so I can show you clearly. That should be 1 minus x. This is also 1 minus x. Here you can just solve this 4x. If you solve that 4x, you will get, let me write it here. What you have here is y equals square root of x. You can solve that 4x. That means you just square both sides. So you get y square equals x. Alright, so you just plug that one over there. You just use that one over there. So you get this equals 1 minus x is actually y to the power 2. Y to the power 2. Okay, so that's y to the power 2. And that is the height of the cylinder. That is the height of the cylinder. All right, now you use integration here. the corresponding formula is given right over there. This is the case where rotation about the x-axis, so that is that. So you could use that formula. So you write it to be volume equals integration. This is your C. It is 0. It goes until 1. X goes from 0 to 1. Okay, and then you have 2 pi. Let me go back. It would be 2 pi y times f of y. 2 pi y times f of y dy. I'm sorry. This is the integration with respect to y. So then you have to find the limits of y, not the limits of x. Actually, y also vary from 0 to 1. All right. This is 0, and here y equals 1. When x equals 1, y is 1. X equals 1, y is 1. All right. So it also varies from 0 to 1. Alright, now you just plug the values. Y goes from 0 to 1, 2 pi y, f of y is 1 minus y square dy, and then you can see 2 pi is a constant, you can take that out. Here y goes from 0 to 1, y 1 minus y square. Now you just unfactor this, you just expand that. Y goes from 0 to 1, y, if you multiply that with that, you will get y, and here you will get minus y to the power 3 dy. And then you can integrate this by using the power rule. So this is y 2, actually 2 means 1 plus 1. Let me put as 1 plus 1 over 1 plus 1. The limits are from 0 to 1, minus y to the power 3 plus 1 over 3 plus 1, 0 to 1. Two pi y to the power 2 over 2, limits are from 0 to 1, minus 1/3, 1 over 4. Here this will be y to the power 4 from 0 to 1. And this is 2 pi y to the power 2. The upper limit is 1. Then you will get 1 minus 0 over 2. Here 1/4, 1 minus 0. Then this equals 2 pi half minus 1/4. And the common denominator, you can just find the common denominator and simplify. So this is actually 2 pi times 1/4, which is pi over 2. Which is pi over 2. Alright, so that is the end of that problem. So we discussed two problems. The first problem is rotation about the y-axis, and then we move to the next case where we discuss rotation about the x-axis. So that is the end of this section. Thank you very much.